In this lecture, we're going to talk about atomic orbitals. By the end of this lecture, you should be able to draw the shapes of the s, p, and the d orbitals. I want to start by discussing what is meant by the term atomic orbital, as I think it is a slightly misleading term. It does not refer to the orbit taken by an atom, but rather it refers to the orbit taken by an electron within an atom. In this model of the atom, which we've been using up to now, an electron can be in one of either three different atomic orbitals. So the electrons can be in this energy level, or this shell, or this atomic orbital, so the first shell, first energy level. Or an electron might be in the second electron energy level, or the second electron energy shell, or it could be in this third energy level. Now, evidence from atomic emission and atomic absorption spectrometry has shown that this model has limitations and it can't actually account for all the lines we see in atomic spectra. So using this new evidence, we've refined this model and to take into account of the nature and number of all the different energy levels that atomic spectra has shown us do exist. There are actually four different shapes of electron orbitals. There are s orbitals, p orbitals, d orbitals, and f orbitals. And I'm now going to go through each one of these in turn and explain what the shapes of these orbitals are. Start off with the s orbitals, which are very similar to our old idea of what electron orbitals look like. They're spherical in shape, and as we go further away from the nucleus, the s orbitals get bigger. So the second s orbital is bigger than the first s orbital, and the third s orbital is bigger still. P orbitals have a slightly more complicated shape. They're a bit like dumbbells. And there are actually three different p orbitals: the px, the py, and the pz. The px orbital lies along the x-axis, the py orbital lies along the y-axis, and the pz orbital lies along the z-axis. When it comes to d orbitals, there is actually 5 different shapes, and you do need to know them all. We'll start off with the ones down here. This is the dxy orbital, and the orbitals lie in between the x-axis and the y-axis. The dyz orbitals lie in between the y-axis and the z-axis, and the dxz orbital lies between the x-axis and the z-axis. Then up here we get the dx squared minus y squared orbital, which lies along the x-axis and the y-axis. And then we get this kind of crazy dz squared orbital, which lies along the z-axis with this funny little donut here around the centre of it. So finally, moving on to the f orbitals. Well, there's 7 different f orbitals. However, you'll be pleased to know that you don't actually need to know the shapes of those 7 different f orbitals. Now, we don't find s, p, d and f orbitals in all the energy levels. In the first energy level, we only find s orbitals. In the second energy level, we find s and p orbitals. In the third energy level, we get s orbitals, we get p orbitals, and we get d orbitals. And then it's the fourth energy level before we see S, P, D and F orbitals. So to finish off, let's just review the things you should have learnt from that lecture, and that is that you should be able to draw the shapes of the S, the P and the D orbitals.